In this screencast I want to talk about recursive functions. Recursive functions are a fairly straightforward concept, but they can be a little bit tricky in their implementation, and there are a few things that you have to be aware of. So a recursive function is a function that calls to itself. So what that means is if I call this function, what will happen is in its definition it will call itself several times to perform the same action over and over. So it's useful for problems which need to be repeated a series of times on some simpler set of data each recurring time. So because the function calls itself, there's a couple of things we need to be aware of. One of which is, obviously, it could be easy for the function to get trapped in just by calling itself over and over and over again. So to deal with this, there's two things that we need. One of them is the base case, which I have here. So what I have here is the factorial function defined recursively. The base case is the case where I call it with n equals 1. And if I call this function with n equals 1, I check, and then if n is 1, I just say f is equal to 1. Okay, so I can show you the operation of that now. I'll put a breakpoint in my function so I can see what this actually does. So I say fact1. I've hit my breakpoint, and I'm just going to return to the screen n is equal to 1. Okay, and I get my answer 1. The more interesting part of this is what happens when n is not 1. So if I call this again, but with, say, 5, I'll hit my breakpoint, so it's checked the base case, it wasn't equal to 1, so it continues on. And now I have the actual meat of this. So what happens is I say that f, my output, is equal to my input value times the output of this function. So this is the call to itself. So what's going to happen now, if I click next on this line, is Matlab will store all my current workspace. So down here I just have n is equal to 5. Matlab will keep track of that, and it will open the function again. So this call, the next call to this function will have its own local workspace scope. So when I click next, what will happen is I should come to this first line of my function, and I did, it's just passed over it. So now n is equal to 4, and if I go to my workspace, n is 4. It's not 5 anymore. So what's happened is Matlab has remembered that n was 5 originally, and then called itself with n minus 1. So now this function has been called with an argument of 4, and it's just going to go through this function again. This is going to happen again, so now n is 4, and it's going to do 4 times n subtract 1, which will be 3. So I call in again, and now n is equal to 3, n is 3, and now I call, the function calls itself again, so now n is equal to 2, and now the function will call itself again, and we should hit this breakpoint now. So now what will happen, we're at the bottom of this recursion now, so we've reached the base case, and what will happen now is it will start returning these values of f equal to 1. So if I click next now, I've hit the end, and I should have an output here, f is equal to 1. So that will be the return value in the previous iteration of this recursion. So I step next now. So now f is 1, n is 1. Now I hit this line again where n is 2 now, and this function returned a value of 1 from the base case. Now I click next again. F is now 6 because I've multiplied 3, which is my n, by the return value from this function in the previous call, which was 2. And I'll step through again. I'll get n is 6 as 3 times the return from this. And that will continue stepping up through this recursion until I get to the end, at which point I'll have an answer of 120, which is 5 factorial. So just a couple of things we need to be aware of with recursion. First of all, as I said, there's a base case, so there needs to be some opportunity for the function to stop recurring. Otherwise it will just call itself indefinitely if I don't have this base case. So if I didn't have this, what would happen is I would try to evaluate f by calling myself again, and I would do that with 0 and then -1, then -2, and that would just continue indefinitely, and the function wouldn't do what I want it to. The next thing I have to have is a simplification. So here notice I'm calling with n subtract 1. So if I just call this with n, I have f n is equal to 3 times the factorial, or times this function with an argument of n equal to 3. Okay, so all that will happen is I'll keep clicking through this, and I'll never reach this base case where n equals 1, because n is always 3, because I haven't simplified or reduced this variable at all, and I'm not approaching the base case, which is what I should be doing to have any hope of ever actually getting out of this. Okay, so what will happen is if I let this run, I'm going to be stuck in this function, and this function will just continuously call itself and call itself and call itself and never end. So computers are pretty smart. People realize you're probably going to stuff this up every once and again. So Matlab has a built-in recursion limit. In this case, it's 500, and if we're not happy with that, we can actually change it. But usually 500 is a lot, but depending on what we want to do, it may not be enough. So if we did actually want to calculate 501 factorial, we might need to change this if we didn't run into other problems first. Okay, so that will prevent you from breaking your computer or locking your system up. So this reduction step is important. It has to be in every recursive function. You have to simplify or reduce what you're calling this with and approach your base case so that you eventually will break the function and start feeding the return values back up through the recursion. Okay, so you need a base case, a simplification, and a call through the function itself. The only other thing to be aware of is, as I said at the start, Matlab remembers everything that you have here. So if I had some matrix which was just zeros, 100 by 100, Matlab will remember each of those variables local to the scope of the function each time, and each recursion of the function has its own local scope. So this variable will exist, and there will be 5 copies of this variable, or a copy of this variable for every recursion. So the point I want to make is, particularly when you deal with large matrices, just be aware of how large the matrices are and how much you're expecting Matlab to remember. So for example, if you had a function which recursed 500 times, and in each of those calculations you were operating on a 1000 by 1000 square matrix, Matlab would have to remember the values in that square matrix each time. So you'd have 1000 squared times 500 million elements that you're expecting Matlab to remember. So Matlab or your computer may not be able to remember that many things, so just be aware of the size of the numbers and values and matrices that you work with recursion.